Hello dear students, myself Ravindra Trivedi. I am the mentor of toppers for IIT and JEE. Okay, so today I am going to discuss important topic of current electricity, that is transient circuit. I am telling transient circuit. What is transient circuit? When resistance is connected with capacitor in a circuit with DC source. I am telling again what is transient circuit. When resistance is connected with capacitance with a DC source, this circuit is called transient circuit. So, how it works? So, let us discuss some properties of capacitor. Capacitor is a device which stores electrostatic energy and charge. If we take capacitor, uncharged capacitor is connected through a battery, then it get immediate full charge, because there is no resistance in the circuit. So, it is completely full charge, immediate full charge, and after getting full charge, capacitors behave as a infinite resistance. So, the current in the flow of current will stop. So, this state is called steady state. When capacitor get full charge, then stoppage of current is there and circuit is in steady state. Okay, there is no current flow in the circuit. So, now if we connect capacitor with some resistance and with the source DC source and with some key at t is equal to 0, there is no charge in capacitor and there is no current in resistance in the circuit. As soon as we connect key at t is equal to 0, the current will start flowing in the circuit and there is a growth of charge. Charge will start building in the capacitor. Charge will start building in the capacitor, but exponentially charge will build. What is the exponential function of charge? I will show you. So, let any moment of time, let Q is the charge on this capacitor and I is the current in this circuit. So, applying Kirchhoff's voltage law, So, what is the Kirchhoff voltage law? If we begin from this point and move across the loops, and total voltage drop or rise, the algebraic sum of voltage drop and rise is taken to be 0. That is the Kirchhoff's voltage law. This law is based on conservation of energy. Kirchhoff voltage law. There is two laws of Kirchhoff's law. Getting my point, bacho? So, how we can use the Kirchhoff's voltage law? By taking sub-sign convention, I have already discussed in the class. So, if we move from minus to plus, then potential difference is minus B, and this positive terminal is there because this is positive. So, this capacitor plate will be positive and this positive negative. So, the voltage drop across the capacitors plus to minus, the voltage drop is plus Q by C. Are you getting my point? And then the resistance, what is the voltage drop? Plus Ri. If we are moving in the direction of current, then the voltage drop is IR equal to 0. This is equal to 0. Are you getting my point, students? Okay. So, now further simplifying this expression. So, we can write here Q by C plus Ri is equal to V, and we can write I as a dq by dt. We can write I as a dq by dt. Then flow of charge with respect to time is current. You know this? So, we writing R dq by dt and q by c is taking that side. So, this is B minus q by c. Are you getting my point? So, now after variable separating, we will integrate, because here is variable, charge is variable. So, we want to find the function of charge as a function of time. So, how we can find? After simplifying, taking the LCM, we get Cb minus Q upon C is equal to R dq by dt. Now, separating variables for integrating, the charge function will take in this side and time taking that side. So, it will be dq upon Cb minus Q is equal to dt upon Rc. Everyone getting my point? Now, integrating both sides. So, we integrate both sides. We have already assumed that at t is equal to 0, there is no charge in capacitor. That is the initial state. So at t is equal to 0, there is no charge in capacitor, charge is capacitor 0. So we can take it 0. Are you getting my point? So at time t, the charge on the capacitor is q. So now integrating both sides. So this integral form, whenever the form is ax plus b, integral of ax plus b, 1 upon ax plus b. So what it comes? ln ax plus b, ln ax plus b upon derivative of this. ax plus b ka derivative, what is the derivative of ax plus b? And that is divided by a. So this is the rule of derivation. So we apply this rule on this expression to find the expression of charge at any moment of time. Are you getting my point, everyone? So integrating both sides. So here we will get ln Cb minus q limit 0 to q is equal to t upon RC. Now putting the upper limit and lower limit and solving this circuit, solving this equation. So ln Cb minus q minus ln Cv, upper limit minus lower limit, this comes out to be this, and that is t upon RC. T upon RC. Okay, and minus is also there because I am integrating this side. So ln Cb minus q upon derivative of Cb minus q is minus 1, because minus 1 minus q have the derivative of minus 1. So minus we also divide by minus 1. So this minus comes here. So this minus comes here. Are you getting my point? So ln Cv minus q upon Cv, we can combine this in single ln. ln a minus ln b is equal to ln a upon b. This is the property of ln function, logarithmic function. So this is minus k t upon RC. So dividing this, so we get ln 1 minus q upon Cv is equal to minus k t upon RC. So now we get 1 minus q upon Cv is equal to e to the power minus k t upon RC. We can convert this function, ln 1 minus q upon Cv is equal to minus k t upon RC. Exponential function and logarithmic function are interchangeable function. We can convert logarithmic function into exponential function in this way. X is equal to e to the power t. So applying this concept here, so we get 1 minus q upon Cv is equal to e to the power minus k t upon RC. Are you getting my point, everyone? So q upon Cv is equal to 1 minus e to the power t upon RC. Now we finally got the expression of charge. Cv into 1 minus e to the power t upon RC. This is the expression of charge at any moment of charging RC circuit. So charging RC circuit, we can this take as q naught, that is maximum charge at t is equal to 0 at steady state, not t is equal to 0, because capacitor get full charge at steady state only. 1 minus e to the power t upon RC. RC is here time constant of RC circuit. What is the time constant? If we multiply R and C, then the product of R and C gives the dimension of time. So it is time constant of RC circuit. Are you getting my point, everyone? So finally we got the expression of charge in the circuit. If we want to current in the circuit, then differentiating this with respect to time, we can find the current expression of current in this circuit at that moment of time. So if we draw the graph of this charge as a function of time, this graph will be like this. Charge will increase exponentially. At t tending to infinity, there is a maximum charge, that is steady state charge, and that is Cv. So students, got my point? So this was RC circuit, which I have explained it throughout. Okay, so thank you.